Okay, we're going to do prime and composite numbers today. You will need at least 2 markers or color pencils, or I like to use highlighters when I'm writing in my notebook, but that's totally your preference. I'm going to glue this in, and it looks like it's sideways. That's all right. Sometimes our pages will be like that. At the top, I'm writing prime and composite. And this is page 12 in our notebook. And then I'm going to flip it just like this so that we can talk a little bit about each of these. Okay, let's go with 2 different colors. We need at least 2 different colors, so I'm going to go with purple and pink. Those are my favorites, and orange. And it does not matter what colors you pick, that is completely up to you. Okay, so let's start out with neither, because that's the easiest one. Neither, I'm going to color orange. And there is only one number that is neither prime nor composite, and that is the number 1. Number 1 is very special. It's not prime, it's not composite. So I'm going to color in 1 with orange, and then I'm done with that. And next, let's go with, I'm going to choose pink, and this is going to be for prime. Okay. The definition for prime is a whole number comma greater, I think I'm going to switch over to a different pink marker, greater, much better, than 1 that has only 2 factors. Those 2 factors would be 1 and itself. So a prime number is a whole number greater than 1 that has only 2 factors, 1 and itself. So you can see in the definition of prime, it has to be a number that is greater than 1. So could it be 1? No. So how do we find these prime numbers? Well, let's think. Let's start with 2. When we think about the factors of 2, there is 2 and 1. Are there any other factors? No. So 2 is a prime number. Okay. So let's stop right there with our prime and go ahead and talk about composite numbers for just a second. A composite number is a whole number comma greater than 1 So once again, it cannot be 1 because it has to be greater than 1, comma, that has 3 or more factors. A whole number that is greater than 1 that has 3 or more factors. So I want you to think about all the multiples of 2, like 4. Okay, I know that 4 is divisible by 2. So 2 is a factor, 1 is a factor, and 4 is a factor. So it has 3 factors. So it cannot be prime. It's going to be a composite number. And so will every other number that is a multiple of 2, because it has 1 itself and 2 and more than likely another number or several other numbers. So we're going to mark out any multiple of 2. Now since these are in nice columns, we can just go down our rows, and any number that ends in 2, 4, 6, 8, or 0 is going to be a composite number. Now I forgot to fill in my key, so I'm going to go back and do that so that I know that purple numbers are composite. This may take you a little bit of time, so if it does and I'm moving too fast, feel free to pause me at any time, and then you can just start back up. Okay, so I have all my multiples of 2 colored in with my composite color. Okay, next we're going to look at 3. 3 has 2 factors, 1 and 3. So 3 is a prime number. So we color that in with our prime color. And then once again, we need to think about the multiples of 3. So I know that 6 is a multiple of 3. It has 1, 6, 2, and 3 as factors. It's already shaded in. But 9 is not, and 9 is a multiple of 3. So I know that 9 has 1 and 9 as factors, and it also has 3 because 3 times 3 is 9. So 9 is a composite number. So we're going to fill in all of our multiples of 3. Now you will notice that every other one is already filled in for us. 6 was filled in, we just filled in 9. 12 is filled in, so we'll fill in 15. 18's already filled in, 21 is not, so we'll fill that in. So essentially you should be able to count, and every 6th number needs to be filled in. So we just filled in 21. 1, 2, 3, 4, 5, 6. We'll fill in 27. And again, 1, 2, 3, 4, 5, 6. Fill in 33. So keep counting to 6 and fill in every 6th number. Take a second, make sure yours matches up with mine. Okay, let's move on to 5. 5 is a prime number. It is only divisible by 1 and 5. It only has 2 factors. But all the multiples of 5 would have at least 3 multiples. So, in divisibility rules, we talked about a number that is divisible by 5 ends in a 5 or a 0. We've already colored in all of our zeros when we were doing multiples of 2. Now all we have to do is fill in the ones that end in 5. Our next is 7. 7 is a prime number because it is only divisible by 1 and 7. Now we need to find our multiples of 7 and make those our composite color. So we're going to count by 7 just to make sure we have all of them. I think we should have all of them but 3. Let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 49 is our first multiple of 7 that we don't already have filled in. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 77 is our second one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 91. I believe that's our last, but just to make sure, 1, 2, 3, 4, 5, 6, 7. Okay. The remaining numbers that we have left are all prime numbers. So take your prime color and fill in any blanks you have in your number line. Now, if you count your numbers, you should have 25 prime numbers between 1 and 100. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Perfect.